Okay, so welcome to section 5.7. We're talking about translations of trigonometric functions. Now, what we've done so far with the trigonometric functions, sine and cosine, secant, cosecant, tangent, and cotangent, is to note that we had functions that were periodic, that we were able to draw using curves like the one below here, and show that they have an amplitude, a period, and other asymptotes in some cases that we could readily identify. In this case, what we're going to do is we're just going to take it one step further, and we're going to work on how can we get a shift up or down or left and right. And we know how that works. We've actually done that before. If you need to review, go back to the chapter that contains it. You'll find that we talked about these shifts. If we're given any function f of x, we shift up or down by adding something to the outside of the function by some positive constant c, or a horizontal shift where x minus c shifts to the right and x plus c shifts to the left. In a trigonometric function, though, the idea is that a shift, a horizontal shift, is called a phase shift. So that phase shift will change depending on what's added or subtracted to c. Now, in the book, they actually give you these formulas. They tell you, okay, amplitude is absolute value of a. Period is 2 pi over, well, they call it the absolute value of b. I would agree. 2 pi over b, though, is what we remember. The phase shift, they're telling us, is negative c over b. Now, before you go crazy trying to remember a particular formula, I just want to point something out. What's going to happen when you have a shift left or right of some trigonometric function is this. If I had this function, I'm going to get a nice thin line that kind of matches this graph right here. What's going to happen, let's say I shifted this graph left or right. The graph would have exactly the same shape that it did before. The big difference between this graph and the graph that shifted horizontally is all of the points that we had before on the x-axis. I'm going to shift off my hand here. That we had before on the x-axis have now been moved by some constant. Okay, they're telling you that constant is negative c over b. I'll tell you the way that I remember phase shift. To find a phase shift, simply set the quantity bx plus c equal to 0 and then solve for x. And what's going to happen is this. If we have this horizontal shift, this phase shift, then what's going to happen is that the starting point of our graph, where it might have been 0 before, the starting point of this graph shifts to that new point, negative c over b. That's our solution. And so what we're going to do is that every single point will shift over that way, and we can just take every single key point that we get along this graph and shift it over by that amount every single step of the way. And so I'm going to run through an example or two where I show that over here. So let's talk about this idea of shifting over a graph. And I'm going to start with this one. Let's say I've got the graph y equals negative 4 cosine of 3x plus pi over 2. I always run through a very specific laundry list of details that I like to make sure I understand for my graph. So how's it going to work? In this case, my amplitude, of course, is going to be the absolute value of negative 4. So our amplitude is 4. Our graph will have minor and maximum and minimum values at 4 points above and 4 points below the horizontal axis. So that's where we'll plot these values. Now, how about the other points? Our period in this function is going to be 2 pi over the absolute value of 3. Well, that's just 2 pi over 3. That's our period. Now remember, however, one of the things that we said was that our key points are always 1/4 of the period apart. So we're going to put our key points here at 1/4 of 2 pi over 3 apart. So 2 pi over 3 times 1/4 gives us 4 goes into 2 twice, and gives us pi over 6 apart. Pi over 6 apart. All right. Now, normally at this point, if there were no phase shift here, we would start plotting our key points by drawing a little x and y table and starting that x and y table at x equals 0. But that's going to change now that we have a phase shift. All right? Since we have a phase shift, here's what I do. I take the quantity that I'm taking the cosine of, 3x plus pi over 2, and I set that equal to 0 and solve for x. So if I set that to 0, I get 3x equals negative pi over 2. And then multiplying both sides by 1/3, I get x equals negative pi over 6. All right, so in my graph now, in my new graph, my starting point, instead of being 0, is going to be that phase shift number. So the way I look at my phase shift is that when I'm writing out my key points, that phase shift number becomes the starting point for one basic cycle of my graph. Now, each of the other key points are pi over 6 apart. So what I would do is that I'd start adding increments of pi over 6 until I get to my endpoint. So if I add pi over 6, I get to 0. If I add pi over 6 again, I get to positive pi over 6. If I add pi over 6 one more time, I get to pi over 3. If I add pi over 6 one more time, I get to pi over 2. So if I'm looking at my graph right here, is the way I'm going to think about it. Here's negative pi over 6 on my x-axis, comparatively speaking. So I'm going to go to my next key point at 0, my next key point at pi over 6. The next one comes at pi over 3. And the last key point at pi over 2. And you might ask yourself, well, how do I know that I'm supposed to end it at pi over 2? Well, first of all, I've got 1, 2, 3, 4, 5 key points. So that's a major thing. I have to have 5 key points, starting with the first one. Key points. All right, so I've got 5 key points on my graph here. But here's the other thing. If I take the end of value, pi over 2, and I subtract from that the beginning value, pi over 6, negative pi over 6, I find that I get pi over 2 plus pi over 6, which gives me 2 pi over 3, and that's my period. So the difference between the ending point on a cycle and the beginning point of your cycle is the period. Now, the rest of this follows what we would normally do for a cosine graph. In a cosine graph, the basic reference function goes 1, 0, negative 1, 0, and 1 again. In this case, it starts out at negative 4, because our multiplier out here, that negative, right, gives us that reflection. If I can spell reflect, it'll be a nice day. Reflects. So start at negative 4. At x equals 0, we're going to go to 0 this time. Pi over 6, we're going to go to positive 4. Pi over 3, we'd go down 0. Pi over 2, we're going to go to negative 4. So in my graph right here, I'm going to start at negative 4 at negative pi over 6. Go through the x-axis at 0. Go up to pi over 6, positive 4, pi over 3, back down to 0. So one cycle of my graph will look about like this. Okay, and you see one thing that's happened here. Our cosine function, right, is no longer starting along the positive y-axis, right? It's starting at a point to the left of it, negative pi over 6. So that's our phase shift. Now, by the formula, you might remember it was negative c over b. And what is c? And what is b? Well, it's equal to the negative of pi over 2 over 3, which we can treat as 3 over 1. And sure enough, that's negative pi over 6. So the way to get the function right here, that phase shift, set to 0 and get your points. Okay, more to come in the next video.